All right, here we go. Algebra 2, Unit 2, Lesson 1. Unit 2 is all about polynomials. Poly meaning many, and nomial meaning terms. So this is going to be things like x squared plus 2x minus 3. That's a polynomial. It has many separate terms. We're going to extend our operations of addition, subtraction, multiplication, division. We're going to take what we know about just doing those with regular numbers and applying those to variable expressions. Today is going to be all about multiplication. So some prereqs that you're going to want for today, because we're going to be multiplying big terms by each other. One thing that's going to come into play is the distributive property. And just so a quick reminder of how the distributive property works, say you haven't memorized your 17s times table. Maybe you have, and maybe you just know 3 times 17 is 51. But something you might do in your head if you couldn't remember is 3 times 10 plus 7. You'd break the 17 up into 10 plus 7, and now we distribute the 3. We distribute the 3 to get 3 times 10 is 30, plus 3 times 7 is 21. So we multiply each part separately and then add up the result to get 51. The same thing works even if you have like multiple terms greater than multiple digit terms. So maybe you just know your 13s tables and you know that 13 times 12 is 156. But if you don't, you could take 13 and make it 10 plus 3. You could take 12 and make it 10 plus 2. And the same idea is going to happen here when you distribute. I like to call this each by each, meaning take each term from the left and multiply by each term on the right. We'll do 4 separate colors here. First, we would have 10 times 10 to make 100. Then we would have 10 times 2 to make 20. This is distribution in action. 3 times 10 to make plus 30. And finally, we'll do gold, 3 times 2 to make 6. And it's a lot easier to do all of this in your head. 10 plus 20, 120, plus 30, 150, plus 6, 156. That's distribution in a nutshell. Splitting something up into separate parts and making sure you multiply each term by each term on the other side. Now, when we do this with polynomials, we're going to wind up with lots of expressions, and sometimes we're going to have to combine them. Just a quick reminder, like terms. We can combine like terms. If you have 10x squared and I have 5x squared, when we add them, all we're asking is how many do we have together? We're just counting. How many x squareds are there? Oh, there's 15. There's 15 x squareds. And we can combine these as long as they have the same variable and the same power. So that's also true for 3x and x. If you have 3 and I have 1, together we have 4. If you have 9 and I have 4, together we have 13. So as long as it's the same variable and the same exponent. You may have an extra step to do here, like you may have, if we are subtracting, you may have a minus sign. I like to just distribute these to make it clearer. So we would have negative 6x plus 3, and then we would distribute that negative. Negative times negative 2 is going to be plus 2x squared. Negative times 6 minus 6x. Negative times negative 10 plus 10. And so I would just go through. I'd like to put this in the correct order from least to greatest exponent. We start with 2x squared. Done. Then we go on to, let's talk about the x's, minus 6x and minus 6x. They're both negative, so negative 6 minus 6 would be negative 12x. And finally, let's do blue. If we had 3 and 10, those would make 13. So you got to remember how to combine like terms there. And finally, the last prerequisite piece of information is that when we have 2 terms of the same base or variable. So like this is a 2 and this is a 2. And we have 2 to the 4th times 2 to the 3rd. The secret here, the exponent rule, is that you add these exponents. You add the exponents when you multiply terms. The reason why this works, if you imagine splitting this up, this is 2 times 2 times 2 times 2. and we are multiplying that by 3 more 2's from 2 to the third. If you count all those 2's, 1, 2, 3, 4, 5, 6, 7, we have 7 of them. So the same idea applies for variables. X squared times x to the third is x to the fifth. We would have x times x, that's your x squared, times x times x times x, that's your x to the third. All together, they make x to the fifth. And so if we had 3x to the fourth, that's 3 times x times x times x times x. This will be the last time you'll see me do this. From here on out, it'll just be understood what's going on. 2 times x times x times x, that's 3, 4, 5, 6, 7. So altogether, we're going to have 3 times 2 to make 6. And if we multiplied 4 x's and then we multiplied 7 more, 4 plus 7, we'd have x to the 11th power. Key point here, if you are multiplying things of the same type, like x's or 2's or 3's or y's, you can add their exponents. And so let's see what this is going to look like when we do multiplication. First thing I could ask you to do is to multiply a monomial by a polynomial. This is just straight up distribution. You'd have here 2x plus 6. That's all that's going on here if it's a monomial, meaning one term, by a polynomial. Same if it's the variable, you just need to add your exponent terms. So if we have 2x times 3x plus 4, well, 2x times 3x, all that is 2 times x times 3 times x. If we did that all together, we'd have 6x, 1 plus 1, if you think about it that way, squared, and then 2x times 4 plus 8x. That's all there, and just the higher the exponent term, the more you'd have to add there to get your final answer. So let's take a crack at example number 3. First, we'd have 5x squared times 2x to the third. That's going to be 10x to the, add their exponents, fifth. 5x squared times 3x squared. That's going to be 15x to the fourth. And 5x squared times 4, that's plus 20x squared. So that's all that's happening there. We're multiplying the coefficients and we're adding their exponents if they're the same term type. In this case, they're all x's, so we are allowed to do that. Where this gets a little trickier is, say we have, we'll do first, a binomial times a binomial. There's going to be two options here as to how to do this. Option 1, and this works for the easier ones, just distribute. X times x is x squared. X times 3 plus 3x. And if these are all in correct polynomial form, it'll work out nicely. X times 4 plus 4x. 4 times 3 plus 12. When I say work out nicely, I mean because if this is in correct form, your like terms will just be in the middle here. You distribute and then you combine. X squared plus 7x plus 12. That's all. Just distribute. If these problems get trickier, or if you just like this method of organization, I'm going to show you something called the box method. In this case, we have a binomial times a binomial. We need a 2 by 2 box. So I'm going to draw myself a little box here. There is nothing different about this math. It is just an optional organizational technique if you like it. On the one hand, we have x and 4. On the other, we have x and 3. And so what we're going to do, this is x plus 4 and x plus 3. That's all that's happening here. It might be a little clearer if I write it like this. X plus 4 and x plus 3. It's just a way to keep yourself organized. X times x is x squared. X times, so see how that's that. X times 3 is plus 3x. 4 times x is 4x. And 4 times 3 is 12. It is just a method of keeping yourself organized. It also can make it a little bit easier to see the like terms here. We'd have x squared plus 7x plus 12. That method is available to you. It is your choice as to which one you prefer. So, this might be a good one to test, like which do I think I'm going to like. If we had 2x cubed plus 4 times 5x squared plus 3, 2x cubed, this is the way I would do it. 2x cubed times 5x squared, that's going to be 10x to the fifth. 2x cubed times 3 plus 6x cubed, 4 times 5x squared plus 20x squared, and finally 4 times 3 plus 12. We don't have any like terms here. All of these are of separate exponent values, so this is simply our final answer. There's nothing to combine here. If you had wanted, like I said, this is your choice. If you like the box method, people usually do every year, you just have to think, okay, I've got 2x to the third plus 4, and then over here, I've got 5x squared plus 3. It is just an organizational method. 2x to the third times 5x squared is 10x to the fifth. 2x to the third times plus 3. That's the exact same math. Just like compare what I'm doing to on the left. Then we'd have 4 times 5x squared to make 20x squared. And finally, 4 times plus 3 to make plus 12. No like terms here. So you would, again, this kind of makes you double write it here sometimes. Plus 6x to the third plus 20x squared plus 12. But you get the exact same answer. It's just an organizational tool. Let's keep it rolling. We're going to do just 2 examples of a polynomial times a polynomial, just so you can see what a bigger example of this would look like. This is the point where just distributing, now we're going to have a whole boatload of these to do, so you might prefer the box method. If we just distribute 2x times 3x squared, 6x to the third, 2x times negative 4x, negative 8x squared, 2x times 2 plus 4x, negative 4 times 3x squared, negative 12x squared. Okay, we're going to have some like terms. Negative 4 times negative 4. Okay, we're starting to see here maybe why someone might prefer the box method, because this is getting a little out of hand, minus 8. So now I have to go through, and I like to just go from highest to lowest. Okay, 6x to the third. That's the only cubed term, so I'm going to write that down here. 6x to the third. Now I look at my squared terms. What I've got here is 8x squared and negative 12x squared. Negative 8 minus 12. It's a negative and a negative. They should get more negative here when we combine them. This is going to be minus 20x squared. So you're going to get a lot of practice with negatives here. 4x and 16x, together those make plus 20x. Notice those don't make x squared. They just make 20x because we're just counting x's. And finally, we have the lonely minus 8. It's the only number here, so it just gets put at the end. That's the just distribute method. You could do the box method. To save a little time here, I'm just going to show one way and one the other, so you just get one of each example. Now let's see what this would look like as a box method. If we did the box method on this separate problem, this is a 3 by 3 box that we would need here to finish this off. So I'm going to draw a much larger box here, give myself room, and give myself room up there as well. Option 2, the box method. Now I'm going to need 2 lines and 2 lines, 3 by 3. It'll at least help me keep organized. So I'll have 5x squared minus 2x plus 6. And then I'm going to have x squared minus 2x plus 1. So again, each box is one pair of the 9 possible pairs multiplied. So the first box is 5x squared times x squared. That's 5x to the 2 plus 2, 5x to the 4th. And then we're going to have 5x squared times negative 2x. That's negative 10x to the 3rd. And then we're going to have 5x squared times 1 plus 5x squared. Then we'll do our next row, negative 2x times x squared, negative 2x cubed, negative 2x times negative 2x, 4, negative times a negative, 4x squared, and finally negative 2x times 1, negative 2x. Final row here, 6 times x squared is 6x squared, 6 times negative 2x, negative 12x, and 6 times 1 is 6. So now what we can do is, one nice thing about the box method, notice how it's going to line these things up really nicely here for us on the diagonals. When we go to combine our like terms, 5x to the fourth is all alone because it's the only x to the fourth term. But then we have this right here. We have you have -2 of something, I have -10 of them. Together, we have -12. -12x to the third. And then we do all of our x squareds. You have 6 of something, Sally has 4 of them, and I have 5. 6 plus 4 makes 10, plus 5 together we have plus 15. Notice it hasn't changed. It's still x squareds. We're just counting x squareds. Couple more, -12x and -2x make -14x. And finally, the lonely plus 6 at the end, nothing to combine. This is your final answer here using the box method. That would have been a bit of a mess to do without the box method. So when it gets to 3 by 3, I highly recommend the box method. The very last thing for today, is just to remember what squaring means. The most common mistake I will see when students encounter a problem like x plus 4 squared is they will try to apply distribution and say, oh, x squared is x squared, 4 squared is 16. Done. This is a very common mistake. You cannot use distribution with exponents. It just does not work that way because it's not what exponents mean. What exponents mean, and this is just what you got to keep in mind, to square something means to multiply it by itself, to make a square out of it. So using the box method, right, notice it makes a square when we do x plus 4 times x plus 4. That's why it's called squaring. X times x is x squared, 4 times x is 4x, 4 times x is 4x, 4 times 4 is 16. If we combine these, we'd have x squared plus 8x plus 16. And so that's obviously very different than x squared plus 16. You have to rewrite this in terms of what it actually means. This is x plus 4 times x plus 4. So I showed you that one using the box method, but this is what it would look like without the box method. And it's only a 2 by 2, so this is one where I probably wouldn't use the box method, but I used it here just to show you why we call that squaring. You can imagine cubing is to take that square and make it three-dimensional. 1 times 2 times 3 is why it's called cubing. But here we go, 3x minus 1 squared. The first thing I would do is I would rewrite this in terms of what it actually means. It means to multiply 3x minus 1 by itself. Then when we distribute, 3x times 3x is 9x squared, 3x times -1, -3x, -1 times 3x minus 3x, -1 times -1, +1. We have 9x squared. If you owe me $3 and someone else owes me $3, together you owe me, that's what negative means, together you owe me $6 is why those combine to make -6 plus 1. There you go. That is how you would square a polynomial. Last reminder, your choice, whether or not you want to use distribution or box method. Typically, the larger the problem gets, the more useful box method will be.